Good afternoon, students. So, in previous three videos, we have solved question number 1, question number 4, and question number 6 of the question bank. Okay. Now, in previous video, this question number 6 we have solved, and in that we have seen that how to use the psychometric chart to solve the numerical. That is, how to calculate the amount of heat removal or amount of moisture removal from the air. Okay. So this we have seen. Now let us see question number 7, that is derive an expression for specific humidity and show that it is a function of vapor pressure and barometric pressure of the air. So this is also very simple question. So what we have to do, we have to just derive the equation for the specific humidity, and in that we have to indicate, we have to show that it is a function of vapor pressure and barometric pressure of the air. So let us see how it is done. So basically this derivation starts from the Dalton's law. According to this particular Dalton's law, you know what is the Dalton's law. So PB is equal to what? PA plus PV. What is this PB? PB is the barometric pressure, PA is the pressure of air, PV is the pressure of water vapor present in the air. Okay. Now we know that specific humidity W is given by W is equal to mass of water vapor upon mass of dry air, right? So that can be written as W is equal to mV, that is mass of vapor, water vapor, upon Ma is the mass of air, that's dry air. Equation number 1. Or it is, let us consider this is equation number A. We know that PV is equal to mRT, and from that we can write M is equal to PV upon RT, right? So by using this formula, we can, if you apply this particular formula for air, so Ma is equal to PAV upon RA into T. This is equation number 1. Now here V and T, volume and temperature will remain constant, so we have to keep it as it is. mV is equal to PV upon RV, and V into T, V by T again here remains constant. This is equation number 2. So what is here? PA and RA. So this PA, okay, in equation number 1, and RA in equation number 1, that is PA and RA are the partial pressure and characteristic gas constant of the dry air, right? And what is PV and RV? These are the partial pressure and characteristic gas constant of the water vapor. Okay. And what is V? V is the volume of the mixture, that will remain same. So from equation number 1, 2 and A, that is we have to put the values of equation number 1 and equation number 2 in equation number A. So if you put that values in equation number A, what we get? W is equal to PV into V upon RV into T divided by PA into V upon RA into T. Okay, so now just what we have to do, we have to reverse it, because we have to remove this division sign by multiplication sign. So PV into V upon RV into T into, it will get reverse, that is RA into T upon PA into V. And here TT get cancelled, VV get cancelled, because it is same for both process. So W is equal to RA upon RV into PV upon PA. So this is equation number 3. But we know that this RA, okay, that is gas constant, can be written as R0 upon Ma, that is molecular weight of the air. Okay, and that is equal to, what is value of R0? That is standard value 8.3143 upon 28.97 is the mass molecular weight of the air. How it is calculated? 28.97. Okay, what is air generally if it is considered as a oxygen? Okay. Okay, so different gases are available in the air. So therefore, the molecular weight of the air we have to consider as a 28.97, and that is equal to 0.287 kilojoule per kg Kelvin. So in maximum amount, if you consider there is a nitrogen, okay, nitrogen amount is available, and the molecular weight of the nitrogen, that is 14, okay, and APV, actually there is a nitrogen, so therefore N2, so 28.97 we have to approximately assume it, okay, and after solving this you will get the value of RA, that is 0.287 kilojoule per kg Kelvin. Now RV, that is for water vapor, can be written as R0 upon MV is equal to 8.3143, that is for SAFE, divided by, so MV, that is nothing but your H2O. So H2 is nothing but hydrogen, okay. So the molecular weight of the hydrogen is 1 and there are 2, so therefore 2 plus oxygen, that is 16, so 16 plus 2, that will be 18. So this will be 0.462 kilojoule per kg Kelvin. Okay, so with the help of this we have got the values of Ra and we have got the value of Rb. So put these values of Ra and Rb in equation number 3. So what is this R0? R0 is nothing but universal gas constant. M is the molecular weight of the air. From equation number 3, we get W is equal to 0.287 upon 0.462 into PV upon PA. And if you solve this, you will get the value of W, that is 0.622 into PV upon PA. Or this can be written as W is equal to 0.622 PV upon PV minus PV. That is here in the Dalton's equation, we have already stated that PV is equal to PA plus PV. So from this we can calculate the value of PA, that is PV minus PV, and just I have put this value here, okay, in this particular equation. So W is equal to 0.622 PV upon PV minus PV, where PA is PV minus PV. Okay, now above equation shows that, if you see carefully, it shows that specific humidity is a function of vapor pressure, that is PV, and barometric pressure of the air, that is PV. Okay, so this is the very simple question. Right? So I hope you understand this particular question. So try to solve this particular question, right? So now the next remaining question I will take in the next video. So you just revise this particular derivation, solve it by your own. Okay, do the practice of this particular derivation. Okay, thank you very much. We will see in the next video.